Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSE, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. This is the lecture number 33 on the course Applied Artificial Intelligence. Today I am going to discuss about the phases in building expert system. So for the preparation of the expert system, what are the phases are required? That is what today I will discuss. These are the topics to be discussed. First, I will explain what is the meaning of the problem domain versus the knowledge domain. Then we will go for the expert system development or the expert system life cycle. This is the topic learning outcome for this phases in building the expert system. So after the completion of this topic, students can discuss the phases of building the expert systems and its significance of each phase in developing efficient and accurate systems. Now let me discuss first what is the meaning of problem domain versus knowledge domain. So domain, first of all, and we already know that domain means it is a particular area. So problem area. So the problem domain refers to the specific area or the field where a problem exists and needs to be addressed. So that area, here the area or the field, that area may be the agricultural field, or the area may be the medical field, or the area may be the educational field, where the problem exists and it needs to be addressed or it needs to be solved. That is called as the problem domain. So it defines what needs to be solved. Especially the meaning of the problem domain is it defines what needs to be solved. If you take the example of the medical diagnosis in medical sector, it can identify the diseases based upon the symptoms. That is what problem domain means. We need to identify in which area the problem exists and how it needs to be addressed. Second one is the knowledge domain. So if we identify the problem in a particular area, then the next step is that problem in that area, how it can be solved. That is, for solving that problem in that particular area, knowledge is required. So the knowledge domain represents the collection of expertise, facts, rules, and relationships relevant to that particular problem. So all these things are required, the rules, facts, and the relationships between the rules and facts and the expert advice from the domain experts are needed to solve the problem in a particular domain, which is nothing but the knowledge domain. So it defines how to solve the problem. In the same example, in the medical diagnosis, if medical sector, medical knowledge means what? The disease and the symptoms, the treatment, the medicines and the injections, all these things are the knowledge about a particular problem. So all these things needs to be fed in the knowledge base so that the problem can be solved in that particular area. So that is why both the domain are important for the preparation of the expert system. One is we need to understand where the problem exists, and to solve that problem, what are the things are required? That is nothing but the knowledge. And how the knowledge can be gathered? Knowledge can be gathered from the domain expert, the people, those who are expert in that particular domain. Now, this is the Venn diagram, we can say. This is the pictorial representation of the problem domain and the knowledge domain. The problem domain always a superset of the knowledge domain here. Okay, so problem domain is the outer circle and inner circle is the knowledge domain. So to solve the problem, so we have identified the problem in the medical sector. Okay, so medical sector. So this problem can be solved. How the problem can be solved? We need the knowledge. What are the diseases, different types of diseases? For each disease, what would be the prescription? Means what the medicine can be prescribed. So all this knowledge can be stored in the form of. How it can be stored? It can be stored in the form of rules, or it can be stored in the form of facts, or it can be stored in the form of relationship. Like this, it can be stored, right? So problem domain is the superset of the knowledge domain. Now, this is very important, especially the expert system life cycle, how the expert system can be configured or can be built. That is what the topic is. So, the development and the maintenance of the expert system, especially it is a life cycle which consists of various stages or phases. Almost 12 states, 12 phases or 12 states are required for the building of the expert system. The first step is identification of the problem and feasibility study. Second one is the knowledge acquisition. Third one is the knowledge representation, then system design, then knowledge based development, then inference engine development, then seventh one, user interface design and development, integration and testing, then deployment, then maintenance and update, monitoring and evaluation, and the final one is retirement and replacement. So out of all the 12 steps, each step is having its own importance. So if we skip one of the steps, we cannot go for further steps. So each step is very important for the preparation of the expert system. So in the first step, let me give the overview idea of all the 12 steps. Then I'll move to further slides so that you can understand. So identification of the problem means what? First, at the initial state, the problem should be identified where the problem exists in which domain. That is called as the identification of the problem. Then feasibility study. If the problem is identified for a particular sector, then we will go for the preparation or the building of the expert system. So should we go for, or if we build the expert system, will it be feasible for that particular area? That needs to be checked. So how that needs to be checked, it can be checked under certain conditions based upon the human power, based upon all the resources, based upon the cost, based upon the environment. That depends upon the area. That is called as the feasibility study. Then second step is the knowledge acquisition, acquiring the knowledge from different sources. Especially the knowledge is acquired from the domain expert. Every time I used to repeat that statement. But apart from the domain expert, we can receive or we can acquire the knowledge from different sources like files or from warehouse, from other documents. So knowledge can be hired. Then after acquiring the knowledge, the third step is representation of the knowledge. So acquiring the knowledge, if we do not store in a particular format, then how machine will understand? So knowledge representation is very much important. We have to store the knowledge in the form of rules or the facts, or we will make some relationships, or we will represent the knowledge in the form of semantic networks, or we can represent the knowledge in the form of predicate logic or proposition logic. That depends upon the type of machine we are developing. Then the fourth step is system design. So system at the fourth step, this is nothing but the architecture of the expert system will be framed. Okay, so system design means the architecture of the expert system will be designed. So inside that architecture, three important components are there. The three important means one is the knowledge base, the inference engine, and next one is the user interface. These three components are planned during this system design phase. So system design means designing or the architecture of the expert system where where the structure of the knowledge base and the structure of the inference engine, as well as the user interface, a description of the user interface will be defined. Then these individual three components along with this user interface will be built. So the knowledge base, then after the architecture of the system design, the knowledge base will be developed. The knowledge base is the main important component of the expert system where the knowledge will be stored, that will be developed. Then inference engine will be developed. So inference engine means where it is the main important component of the expert system which can infer the result by consulting with the knowledge base. Okay, by referring the knowledge which are stored inside the knowledge base, it can produce the result by applying some reasoning and control strategies. Then after preparation of the knowledge base and inference engine, then user interface design and development. User interface means what? how the user, how a layman can interact with the expert system. So that is why some form of interface is required. Okay, so that interface will be designed and it will be developed. Then after the development of the user interface and design, then integration. Integration means all the three components, means the knowledge base, the inference engine, and the user interface will be integrated in a cohesive format, like in a combined format. Then all the three components after integrating, then testing will be done. Okay, so once the testing, why the testing will be done, whether whatever we have prepared for the building of expert system, whether it is giving the correct output or not to the user, that will be done in the 8th step, this step. Then if the testing is okay, then it can be deployed to the targeted environment. That is the 9th step. After that, once it is deployed to the targeted environment or real-time environment, then here the task will not be over. So ongoing maintenance is required, which requires 24/7 maintenance, because after all it is a machine, it's not a human being. So maintenance is needed, as well as if any knowledge needs to be updated, that updation can be done. Okay, then monitoring and evaluation. Though maintenance is required, monitoring means how we can check the performance of the expert system, that needs to be monitored and that can be evaluated. And whenever the expert system is of no use and it is outdated version and it is not required, then it will plan to replace the existing expert system with the new one. So that is the last step. So these are the all 12 steps are required for the preparation of the expert system. Now, one by one, all the steps I will show you. The first step, as I discussed, identification of the problem and feasibility study. So this is the initial phase where the problem domain, this is the initial phase, the problem domain where the expert system will be applied is identified. That is what I discussed. Main thing is the problem domain will be identified where the problem exists. Then the feasibility study will be conducted to assess whether developing an expert system is practical and cost-effective solution for the identified problem. So with respect to various factors, this feasibility study. Feasibility means whether it is feasible or not. So based upon our cost, whether the developing of the expert system is feasible or not, based upon the human resource, based upon the hardware and software resources, based upon the environment. So considering all the factors, the feasibility study will be done. So after the identification of the problem and feasibility study, second step is the knowledge acquisition, where the knowledge will be acquired by the knowledge engineers and the domain expert. They are the very important people for building of the expert system. Knowledge engineers are nothing but they are the AI specialist or AI engineers. They have the domain knowledge. They have not domain knowledge. They have the idea or they have the capability of building the expert system. And the domain experts, those who are expert in that particular area, they may not be. They are like the domain experts. They may not be AI scientists or they may not be AI engineers, but they should have the knowledge in that particular domain. For example, a doctor. So doctor may not be efficient or may not be an AI specialist, but a doctor should have the knowledge in his or her area. So they are called as domain experts. So both knowledge engineers and the domain experts work together and elicit the domain specific knowledge. So apart from that, the knowledge can be acquired using interviews or some documentation review, or sometimes the use of specialized knowledge acquisition tool, even from some data mining tools or from warehouses, the knowledge can be gathered. So after acquiring the knowledge in the second step, in the third step, the acquired knowledge is then structured and represented in a format which is suitable for an expert system's knowledge base. That means what? So after acquiring all the knowledge, because knowledge can be, we can say it can be represented in various formats, but in a structured format, how the system will understand. So based upon the system understanding capability, the knowledge will be represented in a structured format by the knowledge engineer. And this may involve the creating the rules, defining the facts, and organizing the relationship between the pieces of knowledge. Then in the fourth step, the architecture during this phase, the expert system architecture in artificial intelligence is planned. That is what I discussed when I discussed all the 12 points. So architecture means the overview idea of the expert system will be planned, and this includes three important components. So what are the three important components over here? Defining the structure of the knowledge base, first one. Second one is specifying the inference engine, and third one is designing the user interface. These are the three important components of any expert system. So these three things should be defined or specified or designed due to the architecture. It's not like completely designed. The architecture of all the three components will be done at the fourth step. Then after this, each individual, all the three components individually, it will be designed and developed. The fifth step is knowledge base development. So knowledge engineers implement the knowledge base by encoding the domain specific knowledge using the rules and facts defined during the knowledge presentation phase. So especially the knowledge base, as we know that which stores, it is a base or it is a component, it is a hardware component where the knowledge of various expert people are stored. So that will be developed by the knowledge engineers by specifying the domain specific knowledge using rules and facts. Then in the sixth step, the inference engine will be developed. The inference engine, it is an engine which we can say which can process the knowledge which is stored inside the knowledge base and performs the reasoning and is developed and configured. So what happens, the inference engine, what it does, it interacts with the knowledge base, what are the knowledge is stored based upon the query given by the user. It tries to find out the answer by interacting with the knowledge base. Okay, then it produces the answer also. So this includes the defining the reasoning methods and strategies. Means what, how it can understand the question or the query, that is called as the reasoning method. And strategies means how the rules can be applied, the ordering of the rules. So all these things should be defined for when while building the inference engine. Then at the seventh step, the user interface design and development. This is very important. In our normal system, we can interact with our system. How? Because of the operating system. So operating system acts as the user interface. It may be the Windows operating system or Linux operating system. Because of the operating system, we are able to touch our screen and we can on our system, we can move our mouse cursor and we can type the text also. The same thing without the user interface, how a layman can interact with the expert system. So user interface is very much required. So after the preparation of the knowledge base and inference engine, the user interface is designed and developed. The user interface is designed and developed to enable the interaction between the end users and the expert system. So it acts as a bridge between the user and the expert system. So it may involve creating a text-based interface or graphical user interface. As we already know that there are various types of interfaces are available. The interface may be menu-driven interface, or the interface may be the graphical user interface like a Windows operating system which can be represented with the help of everything we can represent in the form of icon. That is why it is called as graphical user interface. Whereas if you consider the disk operating system, it is a type of character user interface where we cannot create the files or folders like the Windows operating system. We have the same features the DOS operating system has, but we have to remember so many commands for the creation of the files, for storing the content inside the file, for copying the files. So those are the character user interface. So that is why interfaces are very much important to interact with the expert system. So which is the seventh step here. Then after the development of the knowledge base, inference engine and the user interface, now we have to combine all the three components together in the eighth step, which is called as integration and testing. So various components of the expert system, including the knowledge base, inference engine and the user interfaces are integrated into a cohesive system. So extensive testing, then testing will be performed to ensure that the system is functioning correctly and provides accurate result. If it does not provide accurate result, that means something went wrong. Again, we have to rectify the previous steps. So testing should be done at the eighth step after the integration of all the components together. If it is fine, then we'll go for the ninth step, where the expert system is deployed in the target environment, or it should be handed over to the user for whom you are preparing the expert system, and the user starts using to solve the real world problems and make decisions in the domain also. Then after deployment, it is there the problem will not be solved. So continuous maintenance is required, which is nothing but the 10th step. So after the deployment, the expert system requires ongoing maintenance. Maintenance in the form of the updation of the knowledge, maintenance in the form of updation of the softwares or any hardware component, that is called as the maintenance. So this involves updating the knowledge base with new information, revising the rules, and addressing any issues or any error that may arise. So that is what it needs to be done in the 10th step. So it is an ongoing task. After deployment, these are the ongoing tasks, more like maintenance, updation. Then 11th step is monitoring and evaluation. Monitoring means the performance of the expert system is continually monitored and its effectiveness is evaluated, as well as the feedback from the user is used to improve the system. How the feedback comes, like whenever we deploy the machine in the targeted environment or to the real-time world, then when the user starts using the expert system based upon their, suppose a user wants to solve a complex problem. So after solving, if he is satisfied with that result, definitely he or she will give the positive feedback. So feedback is very important for the expert system to rectify or to fine-tune the system. So feedback from the user is used to improve the system. Then this is the last step, when we will plan to replace replace our existing expert system. So eventually the expert system may be retired or replaced if it becomes outdated or is no longer useful for the intended purpose. That means if a system which is developed for the particular domain, if it is not useful for the, then we'll plan for the retire or we'll plan for the replace. So this phase involves planning for the transition to a new system or alternative solution. So let me conclude of this. I hope you might have understood this topic. So here I am concluding that the expert system lifecycle, it is a structured approach for developing, deploying, and maintaining intelligent systems that leverage domain-specific knowledge to make decisions and solve complex problems. So it ensures that the expert system remains relevant and effective over time. So this is all about for this particular video. So for this preparation of the video, I refer the textbook Saros Kosik for Artificial Intelligence and the website which is available on the screen. I hope you might have understood this video. Next class, I will discuss about the expert system architecture. So till then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.